here's my patterns of scientific thinking. Luckily, the Project Zero of Harvard, you see, about the nature of scientific thinking, where they create really great materials about key patterns of scientific thinking, which is they also construct pretty good program for teaching new generation about scientific thinking. That is, I think it's really interesting. We may apply it in a practical education program. We want to come into support for P12 or students in the underrepresented groups that they can now they can practice the scientific thinking and understand how the scientific constructs that create the world knowledge. So first pattern, creative and critical thinking. Yep, we don't think science is dry and boring with logic and number, but actually science start with creativity and critical. Of course, critic is something you're testing. We see up here that they say that creative. What is the creative? We start with the new ideas. We think outside the box. We question the nature of the world, and then we connect that imagination with logic, which is critical thinking. Then communicate this idea to others. The partnership, we can cover it in later materials. And many times this idea go against the prevailing belief system, and which happen a lot in the beginning of science. That's why science break out of the idea of philosophy and stand out again religion belief, because we see Galileo, right, Copernicus, Isaac Newton. So I have the examination of the idea of Isaac Newton in here. Isaac Newton is almost try to proving these laws of gravity or gravitation. The formula we have now is hard. Nobody understand it during that time. But how do you prove it? How do you test it? So he need more calculation tools, or you can say that experimental design to test it, because we cannot test how the gravity work in the different object in the planet Earth, right? And we don't know how that falling off the apple falls and everything else is have some kind of the structural and concept. And can human being can calculate it, or we just accept it as a law of nature? Yes, we just don't know. But Isaac Newton, he said that, well, I know it, and I can calculate it. And here's how I calculate it. You don't prove it by the practical, not only by practical evidence, but you also prove it by theoretical calculation and theoretical approach. And during that time, the mathematic concept is not good enough and not even exists. So he invented calculus to work on the number. And that's going to the the Principia of the Mathematica, which is the most significant study of Isaac Newton. So basically, I observe the phenomenon of the apple fall down on the earth and everything else. Why is it happening? And how I can know it, how I can predict it, and how it's different, and how its similarity is. And that's the whole question make Isaac Newton think. And then after you think about, there's something abstract out there. Even now we still cannot explain clearly why, but we have some sort of idea. How do you prove it? You just cannot just collect 10 millions of the object falls from the height to the earth to explain that, because there are billion variants of the object fall out by the gravity. And during that time, they don't have that much of data to share with each other and construct the system of observation. So what do? He tried to prove it by math, right? Math is a language of logic. So well, math, he cannot prove it wrong. And the math system is not good enough. So he created the new math, branches of math to calculate his idea, calculus. So, and you see that during that time, Isaac Newton is still natural philosopher than the mathematicians. But that's how you go it. You think outside the box, and you create the tools to do it. And everybody can do it. All right, so that's why I call that scientific thinking. There's some sort of critical thinking, but in more clear structural. There are multiple ways of critical thinking: model, patterns, sample, idea, case study, philosophy. There are a lot of those, and I find a lot of models, but I think this model is the most simple way to understand it. See the phenomenon, see something happen, see a topic, see the issue, have some ideas. Start, ask a couple questions, right? Why, when, where. So description, the idea, and then you analyze it, right? Go through, analyze it, why and how. This one is not clear because critical thinking is small. It starts from philosophy and they go to different field study later. So that's why it cannot be clear. It got to be big, like a framework to fit up with multiple different way of thinking. It's not every way. You got to be step by step, because when you're touching the different topics, the question, the way to answer the question is pretty different, right? Some philosophy questions, like what is ethics, right? Was it right or wrong, right? When we know it's right or wrong, right? Who decides the right and wrong, and where the right and wrong it changed the definition, and why it's happened like that, right? And how we construct the idea of what the right or wrong, and how even we construct the ideas, right? And what if, right? What if what we know is wrong? What if what we think from the beginning is wrong, right? So so got to pick up the side, and then we evaluate it, right? So what? Okay, now we know what's right, what's wrong. What next? What got to do with the real life? So this model is kind of simple, but I think it's a good framework to starting with critical thinking. But of course, when you have the scientific thinking, you don't see that scientific thinking actually it is the same, but a more clear approach of this. All right, the second patterns of scientific thinking is an extensive documentation. Yes, that is important. Many scientists have notebook drawing, basically. Why they need documentation? Because they can have revision, which just means you write down the idea and you take a look back about the idea and feedback about yourself idea and revise the idea. And then you're helping down thinking to paper and reduce the memory load, because that is our limitation. We all forgot. We cannot remember everything. Well, the AI might be remember everything, but we not remember everything. That's how having note taking and documentation and writing is so important to construct the ideas and mind, and how you deliver the creativity and critical thinking into the work. Okay, you have really famous, well-rounded genius Leonardo da Vinci with 6,000 pages of manuscript in him. Yeah, mirror handwriting. He said writing on the left side, both handwriting. So, and now we got to go through the different years now, 1,000 years now. We're coming back to see that. All right, that's how the genius in 15th century construct his mind and going through his idea, write down his ideas and how we construct it. That's how you can, and that is might be some key idea related to creativity thinking, but creativity thinking is something we cover in different topics. But this topic, we know that writing is important and stretch out ideas is important, because if you cannot make it clear and keep revising, it's hard to be right. That's why in Greenify we really hypothetical emphasize the habit of writing, because it's important. If you're not write down what you think, you'll forget it. And second, when you write down, you see how you can reflect yourself, visually, right? And third, you can give to others for feedback. And fourth, you can do something with that. When we have a well-constructed idea, that this writing is important. Once again, for this idea, I mean, Socrates and walk around and asking questions and understand on his mind. But without Plato's write down the story, nobody know, right? Okay, they have a couple more simple in here from the Harvard project, basically like Einstein as a genius, right? Compare with Newton and other. Yeah, Einstein do write out of 14,000 letters and receive 16,000 something. If we do it now today, we'll do it checking on emails, exchange the knowledge between different scientists and thinkers. Writing is something very nice too. But whatever you do, construct the idea and make it to writing is something have you well organized. What do you think? Charles Darwin do the same thing. He do write a lot. 5 year on his 5 year voyage to the trip to Beja, right? And he makes systematic documentation of his collection, and he writes 16 books. That's basically how you do it. Okay, the third component in here, or the patterns in here, is a strong power observation, basically observation, but you offer the observation much more clear and attention to something different, something interests you more than other people. That's why I pick up this image of the citizen science course when covered later. But see that wear the glass and observe the nature. That's how you start to be a scientist and have scientific thinking. You observe the nature, you watch the flowers, say, why does it have this color? Why does it look like this? Why we need this? Why we need that? And you go back to find the answer of that. That's how you start the scientific thinking. And you practice the critical thinking, right? And you learn something, and you keep learning and learning and learning until you learn that they learn about something that nobody knows. That is basically of Richard Feynman idea about science, doing science. Yeah, scientist is a learner, keep learning and learning, and one day you learn something that nobody knows. That basically how it works. And four, systensis, the information and strong collaboration with other. Basically, you do looking crosswork in different field and collaborate with ideas and communicate with other colleges. That basically cover in literature review and other ideas. That's why I put literature review in here. Important. Have the quote in here. You have to know the past to understand the present. That is something in scientific world. You see that maybe you think something you know now is something really new, something you finding something that saves the whole world or something crazy huge. You should have a couple Nobel Prize for this. But when you do literature review, you realize that someone already discovered in the 1950s, 1970s, where that is the time of science, Western science worlds. It really developed during the time of Cold War and after World War II, because of that time the science, the strong support by society and politics for developed more understanding by human, the country, the society, the weapon, and the worlds, and even the space. That's why the majority of study, when you take a look at lower timeline, 1990, 1950, so 1970, 1990, a lot of discovery we have and cover it there. That's why they got to go through that and dig deeper, because you just repeat other one. That's a pressurization, which is really huge now today in scientific. We don't want to repeat ourselves. We want to find something new, discover new knowledge, right? So that is some sort of basic 7-point idea of why literature review is important. First, right, you understand the concept. Second, you understand the clear topic and what other people do and they cannot do that they can go through, right? Third, you understand the topic, understand what you test, and narrow down the ideas that go to your right track, right? And other stuff is just going to a limitation and define the gap that we need to go through. The science have a lot of gap. What we need to do, fill the gap. That's how it works. All right, and I think that is the last one. Let's have one more. It's 5, taking advantage of serendipity. Basically, yeah, you might catching some discovery by accidents. So scientific thinking and scientists don't have to be doing in the lab and doing tests all the time. Sometimes by accident, by luck. Sometimes experiment bring out surprising finding. So that's why when you're finding that your hypothesis is wrong, well, it's not bad. So at least you get the wrong direction. Go through different direction. It's fine. We still have time to do it. And I think that emerging modern empirical study that we'd like to see the negative results of the test. So we know that this is the wrong direction. We should turn the other round. So that the other round might be taken other direction, or at least feel the further couple more steps. And then it go to the false, and where to go different route. That's how we improve it, right? We just go up like this. We don't know straightforward lineage like this. And if we have millions of people do the same thing, we expand the horizon of knowledge for whole mankind. Well, the Harvard project, according to famous story of Louis Pasteur, who fired a vaccine with accident, left things in the lab, and Alexander Fleming, who developed penicillin by just left this lab and the mole, the dish out there, and go to vacation because cannot go anywhere. But when he come back, you see that the mole eating all the bacteria. That means that this mold has something that can kill the bacteria, and that's the whole part of penicillin. And that is one of the greatest human greatest mistake in human history. Why? It's great because it's saving millions of life of that penicillin during the wartime and during the peacetime now. And to understand about microbiology, it's really helping we develop the future medicine study, pharmaceutical work. So thank to the mistake and thank to the something outside of scientific work, we have developed science. Okay, last but not least, we have the sixth one, the last one. That is scientific thinking. You actually should apply all the technology and resort as much as you have, because that's how you're testing out the future of a study and how you understand the idea of the world. There's a lot of tests, the lots of theory that cannot prove it wrong and cannot prove it's right because of limited technology. If we cannot observe the black hole, we cannot observe the testing out some idea in the universe and law of physics. We cannot see the big generativity theory is work or not. And if we test so small quantum physics, we see that is a work or not of that theory. The technology is something really huge. And here I do quoting some MIT review of 10 breakdown technology early this year. So first of all, of course, we have AI, right? And how they develop the AI and computers, you gotta base on the technology, right? It's the chip. That's why NVIDIA is so huge, so big now, because the cheap technology they make with powerful, empowering the computers, and a more powerful computer, the AI will be much more potential and talents and learning a lot of things with that. So thanks to the technology development, that how we're gonna have all the convenience of using AI for free and all kind of stuff. Okay, super efficient solar cell. So now the solar cell is more efficient. And on their study about the solar power and how to transfer electricity, the power and sustainability development study now is much more developed thanks to the technology improvement of the creating solar cells and engineering. All right, Apple Vision Pro. This one is interesting too. And the technology of that is a collective and huge. Weight loss drug, yeah. So medication like Monjaro and Wegovy, it just depend on the really rising of the microbiologists and pharmaceutical work that can make the drug much more effective now. And now we can more enhance with geothermal system because the new drill technology can drill deeper, new engineering, transferring the energy. Without the better drill, we cannot have a better geothermal study. Well, now we have better stuff to do, technology to do it. Yeah, chiplet, this thing is important. The chip get better and smaller, so we put more chip in the computers, right? That create more powerful computers and even powerful like device like phone. Now you can do a lot of things with that. Okay, first gene editing treatments, and now we have the new treatment, which is what go biochemicals practice based on the new technology, and that you can do ability to cure the sick cell disease, right? Because now they can editing the gene structural computers, which is based, of course, the shipping process and manufacturing is much better. Now can evaluation, simulation. See that they developed these computers and have a more sophisticated simulation of climate, nuclear fission, turbulence, and more. So now other study of climate science, climate change, nuclear powers, and nuclear scientist applications, turbulence energy is much more accurate and much more accessible and go clear to the real data nowadays, thanks to the development of the computers. The heat bomb, right? All right, this heat bomb can run higher temperature, could help decarbonize industry. So that means they don't need to burn too much gas and electricity to create the heat. But now they have a better heat pump that substantially reduce emission will release the air, which is something huge for sustainability development. All right, okay, Twitter killer. Yeah, they do challenge with Twitter. Why Twitter is something really big. It's more like Western culture, more popular in there, and of course, and it is one of the first platform focused on dialogue and discourse. Then other social media that try sharing picture with some partialized idea, which is not well constructed. That's why the power of Twitter. That's why scholar and politicians use Twitter, and businessmen use Twitter more than other platform, because in that they have a strong community. That's basically the difference. Okay, anyway,